Hello and welcome to Physics Teacher. In this video, I'm going to go over a lab I do with my grade 12 chemistry class. Now, if you want to follow along with the lab or you want to use it for yourself, you can download the handout I give to the students for free in the description. First, let me go over all the chemicals and equipment you're going to need for this lab, and then we'll get started. So you're going to need some oxalic acid, and it is 0.1 molar. And then I also have a small 25 milliliter graduated cylinder, a small 50 milliliter beaker. Then I have sulfuric acid. Now these are all fairly low concentrations. This one is 0.5 molar. Again, with a small beaker and graduated cylinder. And then I also have a pipette. It's not completely necessary, but I like to have the kids use it so they get the skills of being able to use it. I also like to have a tray where I keep the sulfuric acid on top of, just in case. Then you're going to need a small 125 milliliter Erlenmeyer flask. This is where you're going to have the reactions take place. Then we have potassium permanganate at a concentration of 0.0005 moles per liter, along with another small beaker, and this is a 10 milliliter graduated cylinder. Then here I have a 25 milliliter graduated cylinder with some distilled water. And then we have potassium sulfate and manganese sulfate. Both I have with a small beaker and scoopula. Finally, we're going to have a cold water bath or an ice water bath. So just put in bunch of water and some ice, and then a hot water bath at about 40 degrees is good. So in this lab for rates of reaction, we're going to start with a control reaction and measure the time it takes for the reaction. And then we're going to add separately two different possible catalysts and see how that changes the rate. We are also going to try different temperatures then and see how that changes the rate. And finally, we're going to try different concentrations and see how that changes the rate. So let's get started with our control reaction. For this, maybe come a little closer. All right, so here's going to be our control reaction. We're going to have the reaction inside of this Erlenmeyer flask. We're going to add the following chemicals in this order. So we're going to start with the sulfuric acid. I have 10 milliliters. And then the oxalic acid, again, 10 milliliters. Then we have distilled water, 10 milliliters. And then the final one is going to be 4 milliliters of our potassium permanganate. Now I like to have this white sheet of paper because it's going to be a very, very pale pink. We're going to swirl it around. We're going to time how long it takes for that pink to disappear and become clear. So why don't we come a little closer for this? 3, 2, 1. So you can kind of see that pinkish color there. We're trying to get rid of that. Let's keep swirling. And I think that's good. So let's check the time. I'll write the results in the description, and let's move on to our other experiments. All right, in these next two reactions, we're going to test possible catalysts with our rate of reaction. So we have our 10 mils of sulfuric acid, 10 mils of oxalic acid, 10 mils of distilled water. We have our 4 mils of potassium permanganate. And then we're going to add as a possible catalyst manganese sulfate. Let's see how that affects our rate of reaction. So we only want a very, very tiny bit, about the amount of a match head. Okay, and let's start swirling. Okay. Okay, wow, I already can't see any more pink at all. That's it. We're done. That was clearly not a possible catalyst, but a catalyst. All right, so let's try this again. We're going to test a rate of reaction, but this time our possible catalyst is going to be potassium sulfate. Let's see what happens. Again, about the size of a match head. All right, let's start swirling. So that's still pink. Okay, it's clearly not as good as the last one. Yeah, I think we're almost there. This one, however, is very similar to the control, so not much of a catalyst at all. There we go. I think that's good. All right, next we're going to test temperature as a factor for our rate of reaction. Here I have a hot water bath, and here I am going to pour ice into water. So let's start with the hot water bath. We have a temperature of about 40 degrees. So let's start with this one. Right? And now we're going to come closer so we can observe. All right, one thing with the hot water bath, you're always going to hold on to it, because if you let go, it can easily tip over. So let's start. I'm going to shake it. So you can see that pink color. All right, I think we're good. All right, so next we're going to test it in a cold water bath. So got some ice, some water. All right, it doesn't have to be perfectly zero, but I just want it to be a fair bit colder than obviously 40. So we can clearly see a difference to see how temperature affects the rate of reaction. All right, it looks like the temperature is about 15 degrees. That's going to be good. Let's start it. I think finally, I think we're good. There we are. All right, in our next test, we are going to be testing how different concentrations affect the rate of reactions. I'm going to first start with a higher concentration of sulfuric acid, and then we'll test a lower concentration. And how we're going to do that is I'm going to use the same 0.5 molar sulfuric acid, but instead of preparing 10 milliliters, I've prepared 15 milliliters. And instead of having 10 milliliters of distilled water, I have 5 milliliters of distilled water. So that is how I am increasing the concentration. So let's look at how our rate of reaction has changed. All right, come a little closer. I think we're getting pretty close now. All right, what does everyone think? That looks pretty good. All right. And finally, to test a lower concentration of sulfuric acid, we have 5 milliliters instead of 10. And then we put 15 milliliters of distilled water instead of 10. So let's test the rate of reaction for a lower concentration. All right, come a little closer. All right, I think that's good.